so this is Vanessa again, talking to you Bio 245 people, and today we're going to talk about tissues because week 2 is kind of what this is all about. And what your job is when you're going to be in class and for quizzes, well, not so much for the quizzes, but definitely for the practicals, is you're going to be looking into microscopes and trying to just determine what kind of tissue it is that you're looking at. So this is one of those times when you'd have your list near and dear to your heart, and you'd be looking at those words and trying to figure out in class, okay, what is it that I'm looking at and how can I arrive at the correct conclusion? Because when you first look at a microscope, it's a little bit confusing. A lot of stuff is dyed a similar color. You're going to see mixtures of red and purple and pink and all these other kinds of things. So things aren't immediately clear. It takes a lot of practice to be able to see what it is you're supposed to see. So I'm going to take you through my reasoning and how I come to my conclusions. And I would encourage you to do the same for yourself. So when you come into class and you're looking at microscopes and you're taking pictures, you can also look at pictures online, of course. There's lots of great pictures of these tissues. Look at them and kind of determine, okay, if I were to just look at this completely blind, how would I arrive at the correct conclusion of what tissue I'm looking at? So the first thing I say when I look at a microscope, what do I see? What is it that I'm looking at? And usually when you look at the microscope, you're going to see a little arrow pointing. So we'll have an idea of like where it is you should be looking. So what kind of thing am I seeing? Am I seeing like densely organized cells with clear nuclei and sometimes a free edge along the side? Or do I see like kind of dense, like a lot of cells that are organized together in like a sheet, so no free edge? And you'll see when we show you pictures later. Or am I just seeing lots of stuff? So am I seeing like mostly space or matrix or like a gel-like kind of consistency with cells scattered throughout, maybe some fibrous stuff thrown in there? So that's the first thing I try to determine. Do I see a free edge and densely organized cells, or perhaps a sheet of cells? Or do I see just stuff with scattered nuclei and maybe some fibers thrown in? So let's start with connective tissue first, because I think it's a little bit easier to come to your conclusions. So the first thing that you can do is kind of determine, okay, am I looking at something that's less solid, so maybe it looks more like jelly? Or am I looking at something that's more solid? So either the color is a little, like the light doesn't shine through quite as freely, or perhaps you can tell it's a solid matrix that has a cell kind of trapped within it. So that's my first thing. Am I looking at more solid kind of stuff, or more like jelly kind of stuff? If you're looking at something that's more solid, that's going to be dense connective tissue. If you're looking at something that's more jelly-like, that's called loose connective tissue. So from there, I can say, all right, what else am I seeing? I'm going to move over here like this. What else am I seeing? Probably the easiest one to recognize that is a dense connective tissue is bone tissue. So the thing that you're going to recognize right away, and I'll kind of sketch this out for you. The thing that you're going to recognize right away with the bone is you're going to see kind of these tree trunk shapes like this. And you'll see like something like this. So anyway, that's the characterizing thing for bone, is you'll see these little tree trunks. And then you go, no, right away, boom, don't even gotta think about it. So that one's easy. The other thing that you could possibly see are different kinds of cartilage. So that's these guys here. Cartilage doesn't necessarily look super solid, but you can tell it's definitely like some kind of solid matrix that has these crazy shaped cells in it that are called chondrocytes. So they kind of look like crazy eyeballs or like two cells stuck together. They actually live inside of their own little space called a lacuna. And there's 3 different kinds of cartilages that you could see. So one of them that you're going to see, again, you'll see the crazy eyeball looking cell trapped within a matrix. And the cells are just kind of dotted throughout. They're not stacked together, if that makes any sense. And you'll see when we see pictures of epithelium. But one of the kinds that you're going to see is called elastic cartilage. So you'll see the crazy eyeball shape, and you're also going to see dark strands that surround the cells and kind of shoot through all that tissue. So that's when you know you're looking at elastic. Crazy eyeballs and dark fibers. The other thing that you can see is fibrocartilage. So fibrocartilage, again, you're going to see that crazy eyeball shape, but you're also going to see surrounding those randomly scattered, crazy looking eyeball things, a kind of solid matrix that's the light doesn't shine through very clearly, so it's not very clear, but you see little eyeballs. This is called fibrocartilage. This is contrasted with hyaline cartilage. So hyaline cartilage, again, you have the crazy eyeball shape, but you have a very clear matrix surrounding it. So clearly these cells are trapped within a solid matrix, like cartilage is very solid, as you guys know. But the cells, again, are scattered throughout, and they look like these crazy eyeballs or like two cells stuck together inside of its own little space. So again, that's a type of dense connective tissue. And these are super easily recognizable. Like you're gonna look in the microscope and you'll go, oh, I see crazy eyeball shape and I see this matrix. I know it's cartilage. From there, it's just trying to determine which cartilage it is. The other kinds of tissues that you can see that are dense, when you look in the microscope at either of these, they're gonna be kind of a solid pink color. One of them is going to be a solid pink color, and all the strands are gonna run in the same direction. Sometimes it kind of looks a little teased apart, like almost like a bunch of hairs stacked together parallel to one another. And you'll also see stretched black nuclei. So you'll see something kind of like this that looks a little kind of like hairy, like so. And then you'll see these long stretched black nuclei just kind of randomly scattered in there, but still all parallel to one another. So this is called dense regular connective tissue. It's regular because it's all going the same direction. So think about like tendons. That's where you're going to find something like dense regular connective tissue. The other thing that you can see, again, it'll look solid pink in the microscope. And to me, it kind of will look almost, I don't know, this is a weird one, like beef stroganoff. Like everything's just in random kind of directions. So it kind of looks like noodles together or something. And then again, you'll see those long stretched out fibroblasts. This is a really terrible drawing of it, but you'll see a picture of it later. But this is dense irregular. So the fibers are the same. So this is generally collagen. Fibers are the same as you would find in dense regular, but they're not nicely, neatly arranged in a parallel fashion. They're just kind of spaghetti-like all together, like beef stroganoff. So for something like dense regular, it's really useful for pulling unidirectionally, so like a tendon. For something like dense irregular, you can pull it from any side or angle. And so that's really useful around muscle, for example, because a muscle will bulge, and so it needs to be able, that tissue that's surrounding it needs to be able to stretch any which way. So that's what dense irregular is really good for. Okay, so that's, again, if you look in the microscope and you see something that's more solid, okay? Again, randomly strewn out cells, or cells that kind of look like nuclei by themselves. If you look at the microscope and you see something that's more like gel or like a cloud, then you're probably looking at loose connective tissue. And there's a few different kinds here, so we'll go through. The most easily recognizable one here is going to be the reticular connective tissue. This is a connective tissue that you're going to find in stuff like the liver or the spleen or other lymph nodes. But it kind of looks like a cut up black fishing net, and some people say it even looks like a cherry blossom tree. So you'll see these like kind of angular branches shooting out like so, but it looks like a black cut up fishing net, and you'll see like little cells inside that are like a clear, usually a pink kind of color, but sometimes amber. But they're like little ball-like structures that are strewn throughout that cut up black fishing net. So there you go, that's reticular connective tissue. Again, easily identifiable. You won't be able to mix it up with the elastic cartilage because, like I said, there are black fibers in the elastic cartilage, but they look nothing like the reticular where you see that black cut up fishing net. Additionally, you're not going to see those crazy eyeball cells in the reticular connective tissue. Next, this one, areolar connective tissue, you're usually going to find it beneath the skin. It does allow for a transfer of nutrients from between different tissue types. And what this usually looks like is kind of like a gel that has fibers shot through it, and they all cross one another. So like one this way, one this way, one this way, whatever. It's just all these different kinds of fibers, and then you'll see these little nuclei kind of shot throughout as well. Again, these are fibroblasts. Fibroblasts are the main cell type that you're going to see in connective tissue that actually secrete the matrix that make up connective tissue. So areolar tissue is always very easily recognizable just because, like I said, it's just these fibers that are shot every which way, so there's no particular order to it. And then, like I said, it kind of looks like gel or something, like you're shining a light through gel, and then you'll see those fibroblasts as well. The other kind of loose connective tissue that you could see is blood. And I know that's weird, right? Connective tissue, blood. What is connective tissue doing? Well, usually it's supporting other tissues that are around it. So supporting other kinds of cells, like in your liver, for example, with reticular connective tissue, that connective tissue is supporting your hepatocytes or your liver cells so that they have something to graft onto. Sometimes they'll connect things to one another, like a tendon connects muscle to bone, stuff like that. or it can offer support in the body. Blood does connect the entire body, obviously. Blood permeates your entire system. So if you look in the microscope and you see something that looks just like clear space with a bunch of red circles or pink circles, you're looking at blood. That one's very easy to identify. The last kind of connective tissue that you could possibly see is going to be adipose. So adipose right here. Adipose is just fat tissue. That's all it is. And it kind of looks in the microscope like honeycomb. So you'll kind of see this like network like so, where you see these clear spaces and they're just surrounded by like a dark ordeal like this. So it kind of looks like a honeycomb throughout the slide. It's very consistent across the slide. The spaces themselves are fat droplets, so you won't see any nuclei in the center of the fat droplets. It's just going to be a clear space, and again, it will look like a honeycomb. So that's loose connective tissue. Moving on to muscle. So again, when you're looking in that microscope, first you're going to see, am I seeing lots of stuff or lots of cells? So we already did the lots of stuff versus the amount of cells, so like the fibroblasts or those cartilage cells like I was talking about. So we already covered that, but that's pretty much just connective tissue down the board. If you see lots of cells, these cells can be in different forms and shapes. So for example, you could look in a microscope and see something that's very solid in like pink color, but clearly divided cells from one another. So you'll see clear ribbons like so, with like striations that go across, like that. Or you'll see something very similar to that, where you'll have these ribbons kind of going across, but they're more branched and segmented from one another, and they have a big nucleus in the center. Okay? And again, you're going to see clear striations. Or you'll see something that's, again, that solid pink color. So this would be solid pink, this would be solid pink. You could see something that's more like a sheet of little cells like this, all stacked together throughout the slide. Okay? So this is a situation where you know that you pretty much just have cells, you don't have just stuff with some cells shot through it. Okay? So if you see something like that, you're probably looking at muscle. And muscle, like I said, is usually pretty easily identifiable. The one place where you can get tripped up is maybe confusing it with dense regular connective tissue, but when I show you guys the photos, I'll tell you guys how to be able to tell the difference between them. So first off, if you see something that's striated, so with these little lines going all the way across it, you have two options, basically. So you either have skeletal, and skeletal tissue, again, there's going to be these long ribbons, very, very long and continuous, with these striations going across it. Or it's going to be cardiac muscle, and you get these more branched cells, again with striations, and with a single large nucleus, usually a single large nucleus, right smack in the middle of the cell. The thing that gets confusing for the skeletal is that skeletal muscle is multinucleated, so you'll see the little nuclei kind of pushed off to the side like this. Okay, so they don't have the big nucleus in the center like the cardiac does. If you see something more like this with a bunch of cells that are fitted together, no striations but solid pink for sure, then you're looking at smooth muscle. So skeletal muscle you're going to find in your limbs, and they support the body. Cardiac muscle, clearly going to be in the heart, cardiac. And smooth muscle you're going to find in places like around the stomach or around your intestines, also around your trachea, just places like that where it's non-controlled contraction. Okay? So that's going to be if you're looking at muscle. The other thing that you can see are lots of cells, again, so like not just random stuff with little nuclei spread throughout, but clearly organized cells. So for example, you would see like a free space or an edge, so it would be white up here, just light shining through. And then you would see just a row of densely packed cells that are nicely organized with nuclei in each one, or with a nucleus in each one. So something like that, or you might see something where, again, you have a free edge, and then you have like a stack of cells, okay? And then they go down like this. But you can see that they're nicely organized. And so you can follow those nuclei in nice little rows all the way down, so they usually look nice and organized. But always for this stuff, you'll see some kind of free edge, some kind of organization of these cells, and each of these cells would have a nucleus. So when that happens, you're looking at epithelia. Epithelia is a type of tissue that just covers other stuff. So for example, even going down the esophagus, you obviously have a hole in the middle of the esophagus, so the tissue facing that hole is epithelia. There's a free edge, right? On the outside of our skin, that's epithelia because it's facing some kind of space, okay? So anywhere where you have some kind of space or you need to cover something, like even the stomach, inside of the body, on the outside of the stomach, that's going to have epithelia covering it, okay? So that's where you're going to find epithelia. The two things to look for with epithelia, again, you're going to be looking for that free edge. You're going to be looking for a basement membrane, which is the bottom line that separates these cells from stuff underneath. So there's stuff, okay. And then you're going to look for how many layers does this have. So if it has one layer, it's called simple. If it has several layers, it's called stratified. Obviously, stratified, like even if you're looking at geography and you look under the ground, you can see that there's stratifications, and that can tell you when a certain layer was deposited, blah, blah. You guys have heard that before. But anyway, so if you see multiple layers in epithelia, they call it stratified, okay? If it's simple, the way that you name it is simply based on the shape. So easy peasy, right? So for example, this layer I drew right here is one layer, so the first word is simple. These are little squares. So seriously, some dude at some point looked in the microscope and he's like, these look like little squares. And so I'm gonna say that it's cuboidal kind of thing. Yeah, cuboid. So this is simple cuboidal epithelia, and that is the whole name. So how many layers does it have? What shape is it? And then put epithelia on the end. That's all you gotta do to name these. So the different kinds of shapes you can see are as follows. You can see from the side, sometimes it'll look eyeball shaped if it's stratified. Other times it looks more like a fried egg, so something more like this. So there's its little nucleus, and then here's the rest of its cell body. This is called a squamous epithelial cell. If you look at it from the top, it looks like a random little polygon, and then you can see its little nucleus in the center. So if you look at it from the side view, it's either going to look like an eyeball or like a fried egg. Particularly, it looks like a fried egg if you find it in the simple form. If you look at it from the top, it looks like this polygon shape. So, so there's your first shape, squamous. So if you see that fried egg, usually it's going to be like in a circle. There you go. And you'll see like these little nuclei that kind of stick out and surround. There you go. So this would be like the lumen on the inside or the free space, and then here's your cells surrounding it in the simple squamous epithelia. So that's what you're going to see if you see one layer fried egg epithelia surrounding some kind of free space. The other kind that you're going to see, like I said, is that simple cuboidal. Usually you're going to see it in a nice straight line like this, but sometimes you'll also see that in a circle, like so. Don't freak out. It's still a bunch of little squares with a free space in the center, so the lumen, and then a basement membrane that surrounds them. So don't freak out, it's still little squares, so it's still one layer, it's still squares, so it's cuboidal, and it's still epithelia because there's free space. The other thing that you can see, usually in a straight line, is going to be simple columnar. Columnar is kind of like cuboidal, but rather than being little squat squares, they're literally little columns, like so. How easy is that? And then they're going to have little nuclei, and those go almost in a straight row, okay? So that's when you know you've got simple columnar. And again, that's how you name it. One layer, simple, looks like columns, columnar, epithelia, because there's a free edge, okay? So it's covering something. And the incident that you see what looks like several layers, or is most definitely several layers, you have a couple more options. Again, it's still based on the name of the shape and whether or not it's stratified. So if you see several layers, you're going to usually either see something that looks like this. So here's your free edge, here's your basement membrane, and it's going to be kind of like that thing I was drawing before, where it's kind of these eyeball shapes, right? So that's going to be that squamous, right? Because remember I drew over here, squamous is going to look something like this or like a fried egg. When it's stratified, it usually looks something like this. So if you see this, then you know, oh, I'm looking at squamous for sure. It's in several layers, so stratified, several layers, squamous, epithelia. It's that easy. The other thing that you can see with squamous epithelia that can throw some people off because it looks weird in the microscope is you'll look and you'll see that the free edge is up here. You'll see stringy stuff and you'll be like, what? But then underneath that stringy stuff, you'll see the nicely organized squamous cells again. Okay? So if you see something like this, where you see definitely that there's squamous cells, but there's stringy stuff on top, this is called keratinized squamous, stratified squamous epithelia. Keratinized just means that there's a bunch of protein on the top. Usually that's our outer skin. Okay? So it's either going to be keratinized squamous epithelia with stringy stuff on top, or it's going to be non-keratinized stratified squamous epithelia. That's really all it takes to name these guys. The other thing that you might see, let me erase these so I can show you a little more properly, is something that looks stratified, but isn't actually stratified. So again, you'll see the free edge, you'll see the basement membrane separating it from stuff underneath, and you'll see something that looks like multiple layers, but if you look close, what you'll see is that it's not actually multiple layers. It's actually one layer of cells, but with the nuclei squished off to different sides. So like there'll be nuclei down here, or a nucleus down here, and a nucleus up here, and all the way throughout. So it's not actually stratified, it just looks like it. So what they call this, because this is still columnar, because it's taller than it is wide, so this is a column, even though it's a weird shape. It is pseudo-stratified. It looks stratified, but it's not. So pseudo always means fake, right? Like if you have a pseudonym, you have a fake name. So pseudo-stratified. It's not for real stratified, it just looks like it. And then like I said, they're taller than they are wide, so they're still columnar. Pseudo-stratified, columnar, epithelia. Epithelia again, because we have a free edge, basement membrane separating it from stuff underneath, okay? The one that I forgot to write up on the board is a weird one. Again, we're looking at an epithelia. So we got a free edge up here, basement membrane with stuff underneath. And what you're going to see for this last epithelia is what looks like little balloon heads, like this, okay? So they're like little balloons. And they're not nicely stacked like you'll see with stratified squamous. Like stratified squamous, you'll see layer, 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 and it's easy to see. With transitional, this is what transitional is, but I'll describe that in a second. With transitional, it's a little bit less organized. It's not nice rows, and they look like little balloon heads. All the way up to the top, they look like little balloon heads, okay? So sometimes the top of that layer will actually follow the curves of those little balloon heads. So very easy to recognize. Often you'll see it kind of curved, so like so. That's usually how you'll see it in the microscope. But again, you'll see that free edge, so that white space, basement membrane with stuff underneath, and clearly organized cells that look like little balloon heads with nuclei in them. So this is transitional epithelia, and you'll find this usually in like the bladder, sometimes the uterus too. Okay, and so some of the, one thing that I didn't put on this stuff for the what do I see, because it's kind of a weird one, is nervous tissue. So nervous tissue is easy to recognize, but it doesn't necessarily fit nicely in these other categories. What you will see, and we'll always focus in so you won't be confused, is you're going to see a big, huge cell. And there's always going to be like stuff all around it, but you're going to see a big, huge cell. It's usually pretty solid looking, and you're going to see branches coming off of it all over the place, okay? So this particular cell is going to be a neuron. Oh, I shouldn't write it on there. This particular cell is called a neuron, and the stuff that you're going to see around it, you're going to see like a gel kind of stuff, and again, you're going to see a bunch of little guys. These little guys are going to be your glia, okay? So nervous tissue, again, it doesn't really look much like these. It looks a little bit like connective tissue because you have a lot of gel kind of looking stuff, but you'll see clearly a large, huge in the microscope, branch cell, and that's going to be your nervous tissue, okay? So when you're thinking about, again, when you look in your microscope, think about what am I seeing? Don't just look in the microscope and say, okay, what tissue is this? Boom. Because you have, what, 20-some terms that you need to know. You have 20 different tissues that you need to know. So trying to look at it and just figure it out right away isn't the way to go, the way to go is to say, okay, what kind of characteristics am I seeing that can lead me to the correct answer? If I see a free edge, for example, check this out. If I see a free edge, I'm not gonna worry about any of this other stuff, right? That cuts it down to 6 that I have to choose from. That makes it easy, right? Free edge, boom, I'm already there at epithelia. All I gotta do is, okay, what shape am I looking at, okay? Has this in multiple layers or one? And for connective tissue, again, am I looking at, lots of stuff in just a few cells, and does that look more solid or more loose? And from there, you can keep paring it down until you get to the correct answer. So don't confuse yourself by looking in the microscope and say, what is it I'm looking at? Say, what things do I see, and how can they lead me to the correct answer?